A tornado outbreak occurred over Illinois and northwest Indiana yesterday on June 11th, 2026. This saw a little corridor of some pretty significant tornadoes in this little region here, outlined by the red dashed area. Some of these tornadoes were pretty powerful and in this fairly populated area. I want to go into the meteorology behind this event, look at the radar, satellite, kind of make an idea of what really occurred on this day and how we saw so many tornadoes in the area, as well as kind of think about why this risk kind of panned out a little further to the south and to the east than was originally forecasted by the SPC. So to start the day, we had a morning MCS move going on over Iowa. You can see on the radar imagery here a pretty substantial MCS, multiple warnings along this line here. It looks like the satellite website is just glitched there. I will turn that off for here. But this was had numerous severe thunderstorm warnings along it as it moved on to the east, as well as some pretty impressive structure radar wise, just with those little wake lows forming these nice comma heads along the line. Um, and as this pretty large system here moved to the east, this would stabilize some of this atmosphere back here, which was expected to recover very quickly. Given a low level jet, a pretty impressive low level jet actually. We expected a lot of moisture return into the area. This is our wrap run at 12Z. We're taking the zero frame because that's essentially analysis, which will let us analyze the atmosphere. But you can see the strong low-level jet placed over Kansas and Missouri. This was expected to slowly meander off to the northeast as the day went on. But I mean, over 30 knots of flow at 16Z is pretty strong, as well as a fair tongue up here with some 40 knots over a large area. Moisture as well, just pushing very far north, was expected after the MCS moved through. So initial idea here is that we have a pretty quick recovering air mass, very unstable, given surface temperatures in the kind of mid 80s, or expected in the mid 80s as the day moves on, but surface moisture, especially in the mid 70s across a pretty expansive region of the Midwest. Regarding our upper levels, we do have a large trough here, helping with the flow. More of the stronger flow is found in the mid levels, 500 millibars, with this main flow affecting the region, leading to plenty of forcing. Vorticity as well, lots of CVA ongoing here to help deepen a surface low over this Iowa region. As well as the expectation to have a little bit of help from some shortwave troughing, notably right here, and supposedly seemingly a shortwave right here as well, possibly a small shortwave ridge here, which could be interesting given how our event did struggle a little bit in this Iowa region. But overall, we did expect a pretty strong amount of flow, a good amount of forcing to be able to quickly recover the air mass and lead to secondary storm development behind the MCS. Looking at our convective parameters, mixed layer cape was well within convective range with over 2,000 joules per kilogram in this green region here, yellow being 3,000 joules per kilogram. So instability was certainly on the table, and a pretty quick a quick destabilization of the atmosphere was expected to maintain itself. During low level instability, by looking at 3 cape here, this is also expected to be quite potent, albeit a little bit further removed in this Iowa region by our 12Z wrap run. But a low level instability was expected over a large region here in Illinois, being able to maintain itself. Looking at our mid-level lapse rates, these will help with some instability and producing stronger updrafts and storms. This did seem to have a good amount of mid-level lapse rates here, solid values here. 8, 7.9, 7.5. I think green is usually above 6.5. So pretty solid mid-level lapse rates, albeit not as strong as you might see with an elevated mixed layer. You'll sometimes see that riding its way from the southwest up here to aid in some stronger storms once they get going above the boundary layer. Lastly, I wanted to look at some other parameters such as SRH, which was quite off the charts, closer to the low. Even here, right in this region in Iowa, was expected to be pretty impressive. Over 100 from 0 to 1, and 0 to 3 being above, basically nearing that 200 to 250 meters squared per second square range. Lastly, as for our morning cams, what gets interesting is looking at SIMREF. Here's our morning 12Z HRRR run. You can see multiple discrete cells. Well, actually, I wouldn't call these discrete, but kind of conglomerated cells here developing in the area. Unfortunately, we lost some of our older runs due to the time of this video, But what was expected was a few convergence bands to develop out here, with some discrete cells as well going on over northern Illinois as the day progressed. This was most likely due to a warm frontal system while the main warm front was further north. Looking at our theta E gradient here, you can see a fairly substantial gradient here being placed over northern Illinois. That would that would be expected to lead to some storm development on the south end of it as that would lift further north. You can see it on the wraparound as well, pretty well here. I'm just watching as the colors affect north. Um, pretty sharp gradient here overall, leading to basically a better environment for continued storm development. Notably, on the Nam Nest run, we did not really have this discrete development out in the open warm sector in Illinois. You would get one or two cells firing along some convergence bands, but a real lack of anything else in the open warm sector here, where we saw it in real life with our storms. So that's a few notes from the models on the day of the event, um, and I think we're going to look into the satellite and radar from here on out. But as our morning MCS moved through, you can note on the satellite a pretty clear area of multiple convergence bands as we originally expected with this air mass recovery, right? However, looking at our service observations, they do tell a little bit different of a story. I'm going to turn off the satellite here for just a second, but notice some of the temperatures here. Um, I would place kind of an air mass recovery zone right here, noticing the 75-degree plot here, but mainly the highest temperatures were still a little bit removed to the south here, 82, 86. Essentially, some of the warmer temperatures were still a little bit removed to the south at that point in time, with our main low somewhat around here. You can see our surface winds kind of moving around this area of low pressure. Um, do keep in mind we do have that MCS moving through as well, which affected the wake low in a little bit, or affected the winds here a little bit with the wake low accompanying it. But essentially, this air mass did not recover nearly as rapidly as it was expected. I'm just gonna try to turn on the Cape overlay here. I'm not sure if that has worked. There we go. This is a good way for us to see how our air mass recovered with time. And notice how this area of higher instability really doesn't get up to the north very quickly. This is 15Z, moving through to 16 and such here. This air mass just does not recover nearly as quickly as was expected. At this point, you already have multiple multiple storms firing within this area behind the MCS, which is part of the reason that we saw the SPC basically shave off a large area of the moderate risk here in Iowa, due to the fact that these storms just were not firing. The main cell that could have gotten going was this one right here, but it just basically fizzled out pretty rapidly there. And as its MCS continued to slowly meander off to the east, it would weaken over this region in Illinois, eventually leaving a little bit of an outflow boundary, which would play a role in developing some storms later in the day, possibly enhancing that theta E gradient like we talked about. Um, but elsewhere, you do still have these convergence bands developing, as well as our cold front draped back here. This is able to be told with the surface plots here. You can see the northwesterly winds out there behind that, but you do have some cold frontal storms here, which did eventually develop some more linear aspects on the line, as you can see here. Take off the watch and warning overlay. You can see the more linear aspect of some of these, but you do still have some of those prefrontal cells that tried to develop. But the story for today, honestly, I think came a lot from the lightning. This is one thing I was watching while I was out there, and unfortunately, there we go. Notice how some of these storms that they develop rapidly, get this very quick lightning production, but then kind of just fizzle out. This is definitely a big question mark for the day. Um, a possible hypothesis for this is that there may have been a little bit of shortwave ridging, as we mentioned earlier on the wrap run. This is something I noticed as well, looking at wrap meso analysis. There was a brief period where it appeared that there might have been a shortwave ridge. Um, perhaps placing with these little kinks in the contour lines here. It'd be a little bit tricky, but it's a potential reason that we saw some struggling storms out here. But another reason also may have simply been instability, due to the outflow, kind of hurting a lot of this instability out here in the basically Davenport region, southeast Iowa, getting into this whole vicinity here. These storms just took a little while to develop, even though they did eventually become supercells as they moved further into a better environment and as the environment continued to destabilize itself. Now, speaking on the environment, I did want to look at some soundings from the day of the event. So the few I'll take from the 12Z look, first is actually Oklahoma, essentially just because it shows a little bit of that the low level jet over the entire region from Oklahoma up to Iowa. This was eventually being evected northward, but even in the morning of the event, Lincoln, Illinois, not much instability to be had in the morning. Not much shear in either of these, which is essentially telling me that um, the shear is still fairly off to the west at this point in time. Unfortunately, Topeka did struggle on its sounding, so we won't be able to trust that one. That would have been a nice sounding for seeing the environment, though, that was being infected further to the northeast. And then we have our Springfield, Missouri sounding here with a little better low-level shear, again, likely due to that low-level jet. Now, looking at our 18Z soundings, I think this one was very interesting. This is our Davenport 18Z sounding, which essentially shows why storms were not developing out in here around 18Z. We were kind of lacking really any instability here at all. That's the wrong sounding. We'll get there in a second. This is our Davenport sounding, though. You can see how much the morning convection really stabilized this environment to the point where the air mass was not able to recover in time. Um, while the shear is very impressive here, though, looking at this looping photograph, very impressive low levels there. SRH in 0 to 1 of about 600 meters squared per second squared. Albeit worthwhile to note that the wake low that we mentioned earlier was likely leading to a little bit more easterly winds near the surface. So this environment might not be exactly what was moving east, but um, still a very volatile environment nonetheless regarding our upper winds apart from just the surface. And the other sounding of interest is Lincoln at 18Z. Instability here fairly impressive. 3,000 joules per kilogram of surface-based cape, mixed layer 2,200. Kind of lacking a lot of shear, however. You do have a good amount of effective bulk shear, 47 knots actually. 0 to 6 shear, 32 here. We're kind of lacking any real notable directional shear. We don't have that classic looping hodograph like you might expect in a supercellular environment, at least not one that produced multiple tornadoes like we saw. But one thing to note here is the convective temperature of 88. So this is taking 18Z. We're already 82 degrees here, and this feels very likely to be hit 88 degrees Fahrenheit. And that was something I was curious about on the day of this event. The last sounding we have is actually from 21Z, also from Lincoln. And remembering that convective temperature, essentially you've hit it at this point at 21, 87 degrees Fahrenheit. The hodograph has improved itself dramatically. Instability is fairly impressive to the point where I was a little bit surprised not to see as much hail with the whole day. If we see the storm reports, there really aren't too many hail reports other than kind of near the central Illinois region. Um, albeit the main instability was likely bullseyed right here in the center of the state, which is why we saw some hail with those initial supercells. We'll get to the storm interactions in a little bit. Um, but yeah, our hodograph and our shear has improved itself dramatically here. Um, effective SRH of 321, 0 to 1 SRH 200. I mean, these are very solid shear values here. Effective bulk shear of 50 knots, surfaces 6, 37. A very volatile environment. Low level instability 178 3 cape. This is a supercellular environment, whether you like it or not. Um, Essentially exactly what you'd expect to see. Maybe not, as extreme as on some of the big days. That's obviously a little bit much, but these surface winds up to this is essentially that speed and directional shear that you always expect to see in a supercellular environment. And this environment did begin to develop supercells very rapidly once you reach that basically right that convective temperature got hit right around 21Z, that Lincoln sounding, showing that uncapped environment. And that is when storms really just started going there in central Illinois and would not look back. They would go ahead and develop multiple supercells that would affect this area here in northeastern Illinois and northwest Indiana. The last sound I wanted to look at was actually taken from my own meteorology department in Valparaiso University, and this is essentially in this little region here, as it's taken at 21, about 21Z. This is taken right here. So you've had this outflow kind of come out from this main storm. And you can see from the sounding, we have, fairly muted temperatures at the surface, not as quality of moisture likely due to that outflow we saw over the region. But the shear the shear here is very impressive. I'm looking at that photograph. Again, the essentially that looping photograph, we have that good curvature in low levels, speed shear as well for the most part. Um, Looking at our shear values here, again very similar to Lincoln, less impressive, but still showing why once those storms got to Northwest Indiana, they still were primed to stay supercellular. Effective bulk shear here was 64 knots, which is very impressive. 0.6 shear 44, that's well within that supercell range. So again, yet another reason why soundings are very important to be keeping an eye on as the day goes on. And the last thing I want to do before looking at radar is kind of monitor how surface observations adjusted with time. You can see our temperatures do very quickly reach 88, about 88 degrees here. And remembering that Lincoln sounding, 88 was the expected convective temperature. We have 88 here, 87, but overall just a very unstable air mass here. Just looking at these mid 80s here with a little bit of forcing aloft. A little bit is a little bit of an understatement, but short waves coming through will lead to enough forcing in this open warm sector. And with convective temperatures aiding in that, this environment was essentially primed for discrete supercells to develop. And also notice how after this outflow boundary kind of kills this environment a little bit, just how quickly it recovers itself. In just 2 hours, noting this station in far northern Indiana there. 72 over 70, 73 over 70, and then 79 over 72. A quick moist air return there. 72 over 70 there. I believe that's Rensselaer. And then quickly back to 82 over 73. The moisture was able to return itself very quickly to this area, which likely continued to prime this environment out here for more storms, which would eventually struggle in the environment as you move further to the east, just having less of that upper level support with time out there. So for this radar overview, I'm going to be having reflectivity on the left and storm relative velocity on the right, just because of the changing storm motions, and it helps keep the couplets look a little nicer with time. And these warnings are going to be usually a little bit removed from the timing, just because the radar scope, the warnings are from the time I archived from. I'm going 2 hours back to show you the loop with time. So we are currently looking at the Davenport radar, and we're kind of in this basically on the Missouri-Iowa border. We talked earlier about the multiple convergence bands. You can see here that these are fairly messy up here to the north. Um, some of them do have a brief couplet or two, but they, again, as we talked about, the instability up there just was not ideal. But as this convergence zone essentially went further south as well, there's a more volatile environment here in Missouri. And if I remember correctly, my screenshot has a violent tornado parameter of 14 out here. These storms were going to fire pretty well with the instability and the shear essentially maximized in this region. But these still did struggle to an extent. Storm mergers were important for this day. Unless instability was more impressive as it was further to the east, where there's just simply warmer temperatures. Um, but yeah, watching these storms develop though, and you notice pretty quickly once they have this bean shape, they get going. And in particular, this cell is the one to be watching. You can notice early on this has that little couplet. Granted, this is very far into the storm, very far up in the atmosphere. I think we're looking almost 10,000 feet, but the fact that this does exist at all is rather impressive here. Excuse me. There we go. This storm continues to develop and pretty quickly earns itself a tornado warning. Even though the storm essentially goes from birth at 2:29 to a tornado warning within an hour from there. So storms were pretty explosive, and given the shear, they were going to essentially give off supercell characteristics very quickly. And one other thing to note here also is just the presence of some storms firing out here in central Illinois, and these ones here, these storms developing southwest of Peoria are also worthwhile. We will be watching those as well with this radar overview. As these storms developed, they still underwent a lot of storm mergers. There were a few storm mergers that would occur, especially with this storm here over Keokuk. That's the one we just saw a little bit ago. I believe this line back here did briefly have a tornado warning with this couplets out here. But yeah, watching this storm develop, you can see again there go the storm mergers, multiple of them here outside of Macomb. And this would eventually lead to a few brief tornadoes. One really nice rope tornado that I was able to see, which is posted on the channel, and I believe a few other ones back here near Carthage, if I remember correctly. I believe it's on the storm reports page, but these are still coming in, just considering the fairly large amount of tornado damage. But yeah, out here near Macomb, there's a few reports seemingly from these interactions that we saw out here. But these storms very quickly would turn into a more linear. We have those convergence bands, and the cold front starts to really catch up to these guys, essentially leading to um, essentially a lack of discrete mode out here as the day went on. And that was expected. It was expected that these storms would be supercellular and discrete, but once that cold front caught up, that was going to be the end of those storms. However, watching these storms that we talked about over Peoria, um, these are worthwhile really watching here. Notice again here, just a kind of bean shape that you'll often see with kind of mini developing supercells, right? You have this general bean shape, likely due to the storms undergoing shear, indicating they're sheared storms and possibly going to develop into supercellular thunderstorms. Um, and this one definitely did still have a little bit of that low level couplet for a little while here. But it really started to actually get going following a storm merger here near Peoria. Um, and as that storm merger occurred, you see a pretty an increase in inbounds to the radar down here. And we'll watch as this continues in a second here. But looking at our storm reports, we did have brief tornado, it seems like, west of Washburn eventually here in 10 minutes from this radar image. We'll continue to watch this storm develop here and notice some of the little higher reflectivities here. As we talked about, looking at our Lincoln sounding, we had at 21Z. We did have a little bit of that increased, kind of lifted index, right? The hail layer did have a little bit more instability, likely leading to some presence of hail here. But notice here some of these cells down here. Essentially here, this is our RFD sinking around, and honestly a fairly low precip kind of look, which is pretty odd given the high PWatt for the day. You can see the hook appendage here, and the velocity really just does not appear very well on radar. But you can infer it given the inbounds here, the outbounds here, which does kind of work out accordingly with the parent couplet developing. But yeah, as this develops here, it's tornado warning. Mergers continue to occur, and you get a more defined RFD at this point, which is where the storm really starts to produce some tornadoes here outside Winona, kind of near Streeter out here as well. These are some of these tornadoes out here. And notice the significant hail report here as well, just with those storm mergers especially contributing to that. Hopefully if I turn on my 4 panel, this should work on the fly. I want to look at correlation coefficient really briefly as well. That'll be in this bottom right corner. That shows the confirmed nature of this tornado occurring at that point in time. Do we have relation coefficient? I just got to work with the radar here. Yes, so it does appear that we do get an image of this, although we're losing our velocity, unfortunately. Granted, we are getting closer to K-lot, so we'll make a change there in just a moment, just to kind of make sure that makes sense. See the little correlation coefficient drop here within the main area of the hook. I think I'll have to make an adjustment here to look at the K-lot radar, though. Yeah, so here's the K-lot radar. We'll go back a little bit to where we were with Winona, but you can see a much more notable couplet here over the city there, with Streeter located here, which is where we ended up seeing some tornadoes. Also, frankly, just noting the echo tops in the bottom left, very intense storms overall in all locations here. Um, yeah, all these storms are pretty intense going up. But yeah, these couplets, we're gonna watch where the couplet locates itself with the correlation coefficient here. Um, yeah, as the storm gets just east of Winona, we saw that tornado report earlier. You do get that little debris, the correlation coefficient drop there, as this couplet really starts to tighten up there. Very, very much a tornado warned storm, and that's a radar confirmed tornado at that point. This debris ball would move on to the northeast as well, just as the storm itself progressed that way, with the secondary tornado seeming to occur kind of with the southern end here of this merger, this cell going up into the main area there. This ended up being kind of where we end up seeing that main area rotation continue, possibly sidling occurring here. I'm not sure how much I trust some of these values here, just given the kind of sporadic nature of them. But you do eventually get that CC drop along that area there as well. Again, CC drop indicating that we have debris in the storm, and that's our tornado in that area. So I'm trying to make sure this is actually under the main storm, possibly somewhat due to the tornado. It's a little tricky there, just with this being on the edge. You have to be careful of radar artifacts with storms like this. But also just noting, as this storm is going on, let me move back to 2 panels for a little less confusion. We have multiple mortar storms firing to the southeast as well. These would pretty rapidly also develop into supercells. I believe a brief tornado occurred somewhere out here near Odell, if I remember correctly. Um, and I was off also southwest at this point, so my attention remembering what was going on at this point was a little bit limited. But um, essentially, the case here is you have multiple discrete cells ongoing here. We have this cell here that's kind of trying to figure out what's going on anymore, probably dying at that point. But we do have a fairly mature supercell here with our main couplet, um, as well as these two baby ones down here. Noticing again just the presence of one or two couplets. Granted, we are fairly high in the storm again, but the presence of these mesocyclones on radar is apparent. And even also an interesting note would be looking at our midway radar. Unfortunately, you don't really get as nearly as much information due to some range folding going on here, but you can get some fairly high level info as long as the storms are close enough. So there's a certain range away from the radar. This basically services Chicagoland itself. Um, yeah, noticing as these storms move in, you can start to see some of the interesting storm features in the mergers, which can help kind of understand what's going on when you're on a chase there. Unfortunately, it's a little bit on the. I went on the wrong time frame, so I will move it forward here a little bit. We'll stay with the midway radar here, and we'll watch some of these storms continue to develop off to the northeast with time there. Hopefully, we're getting our velocity in a second. Come on, velocity. Velocity. That's unfortunate. But anyway, you can see some of the finer interactions here between these storms, and just having the higher resolution can be very helpful overall. Unfortunately, what I was trying to show here with the um, velocity, there we go. So we got our velocity finally. You can see some interesting notes with the velocity. You can see the couplets. Oh, gosh, I gotta keep that. Stop. Pausing that. Here's our Mantino storm, and you can kind of see like kind of the increased outbounds from the thunderstorm, right? So while there is still inbounds to the radar due to the pretty strong southerly winds, you can see the increase in outbounds here before an eventual tornado that would occur in St. John later on. Um, you can see here as well, just with the finer resolution, kind of where these outbounds are occurring and how they're starting to converge in a line here, which would eventually lead to a hook appendage developing, which produced what I believe an eventual confirmed tornado here in St. John. Look at the correlation coefficient on that later, because I believe that is radar confirmed as time goes on. The other interesting note is this storm interaction here. So this is our initial supercell. Again, a little hard to tell due to the low reflectivity. Usually when we have our radars, you'll see some heavier reflectivities just due to the nature of the storms. We have our ongoing old supercell kind of merging with this Kankakee storm. And notice the very quick increase in outbounds as these two merge. So again, kind of watch in this region here and notice how we basically get more of the red on radar as the storms merge there. And this would eventually lead to kind of a dogleg look, but even then, we kind of have this dogleg here. Not much of a real like hook we like we'd be used to, where we see the hook like this. But just noticing the fact that we do have that increased outbounds, that would eventually lead to kind of a redevelopment out here just south of Beecher, where we do eventually get a hook. I will continue that in just a moment on the radar. But that would eventually lead to tornado warnings out in this vicinity here. And based on this same time frame that we just had, again, noticing the confirmed tornado here in St. John, that correlation coefficient drop there. Just the couplets elsewhere being a little more intense, a little more almost vibrant with the other radars. Midway is closer to the ground, so the intensities are a little lower just due to stronger winds due up in the atmosphere. But yeah, noting the other couplets here as well, these other locations. Finally, we'll watch through the last low radar scans before these storms would eventually congeal into the main developing line that was occurring over basically central Illinois at this point. But these prefrontal storms here will continue off to the east as we talked about with this interaction we mentioned earlier. Again, the increased outbounds would eventually warrant more of a tornado warning, basically east of Beecher there, going into Cedar Lake. Though this storm did not, I don't believe this storm continued into a confirmed tornado. But you do have this storm here near Lake Village, Schneider. Lake Village being hit earlier this year in March. Luckily, I don't believe it was hit again. But you do have some of these inbounds and outbounds yet again down here. And this storm down here actually would go on and produce, I believe, a preliminary EF3 as of recording near Couts, Indiana here, and near Hebron. Just looking at the velocity here, very impressive gate-to-gate shear. Taking the extreme pixels here, somewhere around 130 miles per hour. So very intense rotation there, which would maintain itself near the surface. And frankly, I almost don't even need to go to correlation coefficient here due to the fact that you can simply see the debris ball from reflectivity here as this confirmed tornado moved on to the northeast. This would eventually continue on towards Couts, I believe, dropping one or two more out here in northern Indiana out here. And the other last tornado we had to mention here was the same one that went into St. John. This one I am going to eventually go to correlation coefficient, so you can see the two somewhere around the same time frame here. But you do get this pretty impressive redevelopment out here, kind of near Cherville and Maryville, or along US 30. But yeah, you can see the couplet moving to the east. I'll move back a few frames so we can look back at the radar. Unfortunately, just closed it. My little blooper gave me a second to go back to correlation coefficient, so we will go ahead and do that there. Yeah, noting the main storms we had going on, we're going to be looking at this storm here, just watching these couplets, and just the fact that they do become radar confirmed given correlation coefficient here. I am on regular root velocity here now, but you can see the very large increase in wind speed here, 100, 130 something gate to gate shear there with that couplet. And then yeah, you see the very large debris ball that occurs following the storm going through northern Maryville, looks like here, albeit a very populated region here, so lots of damage, unfortunately, just due to the amount of people that are living in this region. Yeah, this goblet would maintain itself until I believe that, as you said earlier, that line starts to kind of engulf it at that point. But our storm to the south there, especially as it's ramped up east of Schneider, kind of near DeMont there as well. A little hard to pinpoint exactly when we get a debris ball. There is an odd, like, kind of correlation coefficient increase, possibly due to just dust going up into the storm. But the main location, I would say, is right here, 754 south of Hebron there. You do get that debris ball, likely due to that debris being lofted higher into the atmosphere. That would increase itself fairly significantly as time went on. And this storm would approach before a kind of, it looks like a brief decrease in strength, but that correlation coefficient debris ball does continue here within that main region of rotation. Gate to gate here on the extreme pixels would be 180 miles an hour. I'll be more hard pressed to kind of call it 100, maybe 100, 140 probably, 150. Still extremely strong rotation there with that storm. I believe there's actually some ground scouring you can find on the internet from that thunderstorm as well. But yeah, that would be basically the end of the tornadoes. There would be some more, I believe one or two as this continued on to the northeast a little bit, but the main line would kind of engulf a lot of this, if I am remembering right. There may have been one or two brief keel CSs as well, keel CS tornadoes as this line propagated to the north or to the east, but the main supercell thunderstorms for the day were about done following sundown. But that is about all I have for this video. There's a few definitely many interesting things that happened with this day. Just considering the failure of some convergence bands out here in Iowa, just the open warm sector development. Lots of things were really interesting about this day, and I do think it makes a very interesting weather discussion. Mainly, again, just looking at the main ideas, morning MCSs always make days more unpredictable, and that was a very big forecast uncertainty looking at this day. Just see that morning MCS hurting a lot of this environment out here, even though we did expect an improvement with time. And also just the impressive nature of these supercells in the open warm sector. Um, just kind of goes to show that when you do expect a weaker MCS in the morning, that can affect your forecast accuracy to an extent. But yeah, definitely interesting weather discussion. If there are any questions, anything I'd love to comment. Look in the comments and stuff, talk about that kind of thing. I live for weather like this, and with this being in my area, I thought this was a pretty interesting kind of case study day. Definitely some interesting supercells in the Northeast Illinois, Northwest Indiana region. Just yeah, definitely an interesting day. But those environments, if you end up with an environment with, 200 meters squared per second squared of effective SRH, 4,000 joules per kilogram of K, your day is going to those supercells are going to develop very rapidly and intensify very quickly. So that's about all I have for this video, though. Again, thank you all for watching, and I will see you all next time.